Before the at-home experiment, I want you guys to read the short introduction in today's assignment. And then you are also going to be working on some pre-experiment questions. So this is what I'm going to actually go over in this video. So make sure you do the reading to understand what's happening for the at-home experiment. And right now I'm going to go over the pre-experiment questions. All right, so it says, number 1, balance the chemical equation, the chemical reaction equation for the decomposition of sodium azide. All right, so if you did the pre-lab reading already, this reaction, so the decomposition of sodium azide, is actually the real reaction that happens in an airbag that's in your cars. All right, so this is not the reaction that we're going to do at home because we do not have these materials at home. So that's why we're going to use baking soda and vinegar instead. But it says number 1, balance the equation. Okay, so I'm going to do that quickly right here. So I see there's 1 sodium and 1 sodium on each side. So sodium is good so far, but if you see nitrogen, we have 3 nitrogens here and 2 nitrogens on the product side. So I need to make them equal on both sides. So I'm gonna pick our magic number 6 because 3 and 2 both go into 6. So I'm gonna multiply this 2 nitrogens by 3. And then I'm gonna come to the reactant side and multiply this nitrogen by 2 to get 6. So this means that if we put that coefficient of 2 in front of Na and 3, we need to also multiply the Na by 2, which means we need to put a 2 in front of the Na on the product side. So now everything is balanced and we are happy. All right, number 2 says, so the chemical equation below is the reaction we will be performing in our experiment. All right, so we have this long equation, but I also put a sentence interpretation. So basically this reaction is baking soda reacts with vinegar to produce aqueous sodium acetate, water, and carbon dioxide gas. So this reaction means this. All right, so we're basically adding baking soda and vinegar together to produce sodium acetate, water, and carbon dioxide. So what's gonna fill up the bag is carbon dioxide gas, right? Gas is going to fill up the bag and act as the nitrogen gas produced in a real airbag. All right, so that's what it is. So now I want you to calculate the molar mass of baking soda and then calculate the molar mass of acetic acid. So let's do that quickly down here. So I'm gonna make some space. So calculate the molar mass. So I'm gonna look at my periodic table. Make sure you have that ready. So we have sodium is 22.99 grams. Hydrogen is 0.01. Carbon is 12.01, and then oxygen is 16, but we have 3 of them, right? And if you do the math, I think, so I'm gonna do the math on the calculator and I get 84.01, but I'm just gonna round this to 84 grams per mole. All right, so this is the actual number that I'm going to use for the lab and all the calculations that I do. All right, so this is the molar mass of baking soda. All right, so now let's calculate the molar mass of acetic acid. So acetic acid is what's in vinegar. I see there's 1 H here, but there's 3 of them here. So I'm going to do 4 times 1.01 for hydrogens. Carbon is 2 times 12.01, and then I get 2 oxygens, so 2 times 16. And if I plug that into the calculator, I get 60.06. So I'm just gonna round that to 60 grams per mole. and this is molar mass of acetic acid. All right, so this is the number that you're going to use for all of your calculations that you will have to do for your experiment. All right, next question is actually a very important question. It says vinegar is 5% acetic acid. This means that in 100 milliliters of vinegar, which also means 100 grams because the density of vinegar is 1 grams per milliliter. So in 100 mils of vinegar, there is 5 grams of acetic acid. So 5% means there's 5 grams of acetic acid in 100 grams of vinegar. So if we have 35 mils of vinegar, how many grams of acetic acid do we have? So it says 5% of 100 is 5 grams, right? So it's asking us what's 5% of 35. So to do this math, I don't know if you guys already learned how to do percentages. So basically we have to change the percentage 5% into a decimal, which is 0.05, right? We just divide the 5 by 100. And so 5% of 35, we're going to multiply 35 times 0.05, and you should get 1.75 grams of acetic acid in 35 mils of vinegar. All right, so this is your answer for number 3. So in the lab, you also need to calculate how much acetic acid is in however milliliters of vinegar you use. All right, so I will go over that again probably as we're doing the lab tomorrow or Thursday. All right, so let's do number 4 now. So number 4 and 5 is where you're going to show your stoichiometry skills. All right, so we have to do some mole conversion and mole ratio to get the answers for these questions. All right, it says if we use 20 grams of baking soda is our NaHCO3, right? How many moles of sodium acetate can we make? How many moles of sodium acetate? Sodium acetate in our equation is NaC2H3O2. I'm getting this from our equation up here. So I'm going to actually copy and paste this equation down on the bottom so it's easier for us so that we're not going back and forth. So I'm going to Control C and then add our equation right here. All right, so now everyone can see. All right, so if we use 20 grams of baking soda, how many moles of sodium acetate can we make? All right, as soon as you see the word grams, you should be thinking, oh, I need the molar mass of baking soda. So molar mass of baking soda, we figured it out on number 2, is 84 grams per mole. Right, so if we have 20 grams of baking soda, how many moles is that? So we need to divide by molar mass. So 20 divided by 84 is 0.238 moles of Na, so that's baking soda. So, but the question is asking how many moles of sodium acetate can we make, right? So we're trying to get moles of sodium baking soda, 2 moles of sodium acetate. So we have to do mole ratio, right? We have to do mole ratio between baking soda and sodium acetate. So if you look at our chemical equation, which is our recipe, you see that there's no coefficient in front of each of these reactants and products, okay? And this equation is actually already balanced. So that means everything is just 1 to 1 to 1 to 1 to 1 mole ratio. So we need 1 mole of baking soda and 1 mole of acetic acid to create 1 mole of sodium acetate, 1 mole of water, 1 mole of carbon dioxide. So this is a very easy equation. It's just everything's 1 to 1 to 1. All right, so when we do the mole ratio out here, we don't even need to do the math out, but I will just write it just so that you guys understand. So basically it's 1 NaC2H3O2, which is our sodium acetate, over 1 NaHCO3, which is our baking soda. So it's just going to be 0.238 moles of sodium acetate. And this is our answer. All right. So because everything is 1 to 1 to 1 mole ratio, the math is really not that hard. You multiply by 1, you get the same moles. So now the next part is how many grams of sodium acetate. So here's the part where you actually have to plug into the calculator. So we know that we have 0.238 moles of sodium acetate. In order to get the grams, that should ring a bell, we need molar mass of sodium acetate. And I'm going to do that quickly. In my calculator, sodium is 22.99 plus we have 2 carbons plus we have 3 hydrogens plus we have 2 oxygens, and I get 82.04 grams. I'll also put it over here. So we're going to multiply by the molar mass and get 19.52 grams of sodium acetate. All right, so this is my answer for, let's go back, erase that. This is the answer for my grams, and then this was the answer for moles of sodium acetate. All right, so the next question is going to be very similar to number 4. It says, if we use 100 mils of vinegar in the reaction, that is 5 grams of acetic acid. So we're given 5 grams of acetic acid. Acetic acid is HC2H3O2, and it's asking how many moles of carbon dioxide, CO2, is produced and how many grams. All right, so it's the same exact type of problem as number 4. All right, so we're given 5 grams of acetic acid, so we need to set up an equation where we get the moles of acetic acid. So we're going to divide our 5 grams by 60 grams because that's the molar mass of acetic acid. And I get 0.083 moles of acetic acid. So I'm going to label it 3O2. But we want the moles of carbon dioxide, right? We want the moles of carbon dioxide. But remember, everything's 1 to 1 mole ratio. So basically, whatever moles we have for acetic acid is the moles of carbon dioxide. All right, pretty easy. And now it's asking for how many grams of carbon dioxide. So we're gonna bring our moles of carbon dioxide and multiply the molar mass of carbon dioxide, which is 44 grams. All right, so I'm gonna do 0.083 times 44 grams, and I get 3.65 grams of carbon dioxide, and that is my answer for how many grams. All right,